Okay, so welcome. Good morning, ladies and gentlemen. It's a pleasure to welcome you this morning to our MED1stMR webinar. I hope you're all doing well and you're as excited as me to get some news about the technology in mixed reality. My name is Birgit Hartung. I'm at the MED1stMR project responsible for dissemination and exploitation, and I work for UseCon. We are a usability consultancy in Vienna, and today I will be your host and guide you through this webinar. And if you need anything, I will be here to answer your questions as well. But before this, some information on the webinar. Today is, we have a series of 3 webinars. Today is the second webinar. So if you're interested in the first one, it's already recorded and downloadable at the YouTube channel, and you also find it on our website. And today is the second one. It's about the technology that is used in our research and technology project. And it will also be recorded and be available afterwards. For your convenience, so today we start with this short introduction by me, and then we have about 40 minutes of presentations from our technology partners, and then at the end we will have 15 more minutes of Q&A session. And if you have questions already in between, just post them in the tab that it's called questions / chat. And then at the end we will answer them or already in between in a written way. Okay, and then now let me introduce you to our speakers today. We start with Helmut Schramm-Feiertag from the IIT, Austrian Institute of Technology, from the Center for Technology Experience. He is the coordinator of our project and will introduce you to the project and give you some information also about the technology aspect that AIT brings into the project. Then we'll Oliver Scherer from Refens AG will present you the VR aspects of our project. Afterwards, Davis will give you some insights on the manikin that we use in our project and the mixed reality aspect. And afterwards, Pedro from Flux Biosignals will give you insights on how do we measure stress in our project and how this will be visualized for the trainers. And Daniel will give you an overview about how does all this technology come together, how is the software architecture and the backend constructed, that this all in the end is a usable solution for our trainees and our users. Okay, so thank you for that. If you have any questions, I will be in the chat, and I will now hand over to Helmut, who will give you some introductions on the MED1stMR project. Thank you.
Okay. Hello and welcome everybody. It's a pleasure for me to introduce you a little bit about MED1st. So I will give you at the beginning a short overview of the project and how the technology plays together and which technologies we are talking today. This is only a brief overview. For a more extended overview, you can see our first webinar. There is more about the project and also like the research approach, what we are going for in our project. So coming from MED1st, our initial situation is like, so we see an increase of disasters in the last time, man-made and natural disasters, and that also has sometimes mass casualty incidents with it. So that means high number of injured people, and that brings high efforts to the medical first responder. They are first on scene. So this is where the resources of the medical first responder are too low to deal with the high number of injured people, and that needs a different kind of care. So that is not they have to do the medical care, they are not able to do the medical care for all, and so they had to start with the triage process. So that means making a prioritization, a situational awareness, and then starting to assess who has to be treated and rescued first and brought to the hospital. And these are things they are not trained as good or as much as the first responder would like. So that means there is a need to train more often for mass casualty incidents. So why we are say mixed reality is a solution. So it gives us the opportunity to immerse the users in a computer-generated stressful situation. So they experience this disaster situation, and they can train more often, more cost-effective compared to a large-scale exercise. And that means in this environment, there are the collapsed buildings or crashed cars, trains, and also the people are simulated, the injured people with the wounds, and there is also like the progress of the injuries are simulated, so and they can start with their medical treatments. And this, in our approach, is like there is nothing to touch in normal virtual reality training. So in our approach, we include now a high fidelity training patient simulation manikin, and that enables really practical medical skills on that mannequin. And together, we also extended so that the trainees get measured with wearables for about their ECG, and out of that we compute a stress score, and that helps the trainer to assess if the situation is appropriate for the training, if the trainees are stressed, overstressed, or the scenario works for the training. So to improve the training performance, and could be personalized on the needs of the trainees. So to present you first the consortium, we are 18 partners across Europe from 9 countries, and we have 7 end-user partners in our consortium. So that means a lot of experience and input on requirements, and also like in the evaluation that helps us in our user-centered approach. To coming to the mixed reality training solution, so we are, let's say, with our solution, we come up with a training approach that is like, in the first step, people are immersed. So they jump into with the equipment, then go into the training, and then see in the mixed reality the scenario. And in that scenario, all the environment is simulated, so that only this small group is physical. They are doing the things, and everything, a large scenario can be simulated in there, and gives us a complex situation with high stress. And also there are included the mannequins, so that they can also train for medical skills. And as said before, everybody is equipped with a wearable measuring the stress, and gives that as a feedback to the trainer in real time. At the second part in the center, there you can see this scenario control with this real-time measurement of stress KPI, so about the performance. So the trainer can decide if the training has to be altered in real time, or something has to be made for the next scenario. Some changes or improvements on the scenario can be done in a scenario editor then for the next one. And also all the things they are doing in the mixed reality is recorded. The complete body tracking, the movements, everything is recorded and can be replayed then for the debriefing in a 3D manner, so that you can change perspective and can jump into the specific points of time. So the trainer has also the possibility in the real-time training, so to set markers and jump quickly then to these points in the debriefing. And this discussion is quite useful. So after the training, so to go into the things, why things happened and what was the cause on that. So to give you an overview how that will look like in reality. So here you can see a scene, so where the training system is installed. Here you see the training area where up to 4 people are now can be equipped with mixed reality equipment and can train together. Then in front, then you can see the trainer view. There is a dashboard. He sees where they are in the scenario. He can also change the perspective so that he sees a first-person view of one of the trainees, or of a top-down view, or other freely views that can be chosen. Then we have the trainees, up to 4. They are equipped with the headset, with the tracking system, and we have then also the real patient simulation mannequin. All the trainees are equipped with the biosignal measurements, so to get the feedback on their stress score. And then you see what they will see or experience in the mixed reality. This is a preview of a scene. So that means everything is overlaid with a virtual representation, and he can interact with some of them physically, and with the others, they are more or less visual appearance to them. We have also multisensory, that means also audio, and maybe we will also use olfactory devices for that. And there also is shown some scenarios. So the first responders see themselves in the full body, they see their uniform, they see then the scene. There's an example of a crashed bus and other virtual things. And all the things are all collected in a backend system so that it gets further analyzed from statistics, and also to use this information for the design of new scenarios, also to learn from the behavior of the trainees to adapt them to the scenarios. So what technology is combined? So to give an overview, what are the partners and the technologies? So this is the list. At first, there is the AIT, where I'm working. So at the Austrian Institute of Technology, our main focus is that steer the user-centered development and the user-centered design, talking to the end users, gathering requirements, do the evaluation with them, and also like provide prototypes. Prototypes to them, and so that they can see. No, not sending. So it's again. Sorry for that. We also provide small prototypes to have a forerunner system, so to test things in an early stage and then implement it in the large system. Then Refence, they are developing and supporting the VR system, the environment, the technology. Then we have Mind Console. They are creating the virtual content, so all the assets they are necessary for the creation of the realistic scenario. We have then D2T Medical X, so they provide us with their simulation, high fidelity simulation manikin. So that is linked to the VR system so that they interact. So what is done with the manikin is also registered in the system. And then we have plugs with their biosignal measurements. So they create wearables so that we can use that in an easy way and equip the trainees with that for the stress measurement. And then we have finally our partner IDENA, that is doing the collection, the storage, the assessment, and all the models to train AI and other statistical models for the analysis of the trainings in it after that. So then I will hand over then to our technology partners. So the first one is from Refence. So hello, Oliver, and I will hand over then to you.
Thank you very much. Well, first off, short check. Do you hear me? Yes. First off, coming from Refence, our background is to provide different scenario-based virtual reality training for law enforcement courts in Europe and in the US. What we learned there is actually that we have a lot to do that people really can get into virtual realities and really to kind of immerse to these scenarios. So what we see is that actually the scenario preparation is quite important, because you have to give the participants the chance to enter the VR world that you built before for them. And with all those, I think, technical environments that we provide is also the first step when these participants arrive in the virtual world. It's really important that they also can accommodate not only to the virtual world, but also to recalibrate them in a very technical way before they start with the training. Therefore, we developed a flexible scenario editor, which allows the instructors to not only control the environment during a training, but also to really create a new world for each training. We also developed not only special enhanced VR goggles, but also hand and foot sensors, so that actually the whole body is transmitted to the virtual world and every movement of the participant is shown in a real manner in the virtual world. As Helmut mentioned before, we also have it all come together in the end after or during the training and after the training in a dashboard and in an operator control, where actually all these data points get stringed together and not only can be measured, but also can be used for a better learning effect for the participants. So I will just try to click, and yes, it works. So just that you have also kind of a visualization of it, to enter the VR world, we built a setup that you see here with the full body VR kit that was mentioned before, but also with a training field that consists of these metallic trusts with up to 40 cameras, which are actually tracking every movement, not only of the participants, but also of mixed reality assets that can be implemented. And we also have this built VR world that comes out of the computer, and this is actually kind of conducted by the instructor. And this actually makes it very, very easy, that is what we learned so far, to immerse in this scenario, because every movement is quite smooth and quite direct in the virtual world. So the participant feels like really getting into this environment. And the benefits lie actually on the hand, and this is when the participant is in the training, they not only train, but they learn through actually application of movements and processes, but also have the possibility to not only learn through doing, but also through understanding. So from a meta perspective, they can have it in the after review to really gain an understanding of what happened and what was good and what was actually bad. And when we talk about the equipment in general, that is actually the setting or the VR basics, is that we have these full body VR kits consisting not only of these parts I mentioned, but also laid out for up to 4 participants. One operator, the operator doesn't need to go into the VR world, so he stands actually behind the desk, conducting everything from beside the training field. And at best, 1 to 2 trainers who can not only advise the operator, but also have an overview of actually what the participants are doing, to have a very, very quick debriefing right after the training, so that this train and learn and understand effect is really, really close together. So in a nutshell, we from Refence try to make it possible to enter the VR world and to train there. And now I hand over to the next speaker, I guess.
So now I will hand over. So thank you. One huge element to create immersion are the VR assets and the tangible objects. They are available in the mixed reality. So that means in our approach, we are using mixed reality in a special use case that is also called augmented virtuality. So that means everything that the trainee sees is virtual. So he sees only digital information, but behind some of the virtual objects, there is a real physical object behind, and he can touch and operate and use the things. As we said before, this could be one of the medibags, this could be a triage card, and this will be also like this manikin. And for all these assets, they have to be created the appropriate avatars and physical objects and representation. And also you can see here the crashed bus, so that gives you the impression that there really physics has been involved and there why people are injured. So from injuries, then that means also like coming to that creation of the injuries. So there is no real database now available for 3D models of injuries. What you see mostly are textures, but if you will have also like real hard seriously injuries, you will have also 3D representation of the injuries, and this is also developed in our project to provide more realistic injuries. So because if you want to train people on treat injuries, then the injuries has to be represented realistically. So now I will hand over then to Davis. So starting with the manikin.
Helmut, thank you very much. I'm Davis de Miras. I'm the CEO of MED1st. So what we're using is a manikin that's going to represent a virtual body inside the virtual reality environment. The manikin we chose is a high fidelity manikin. That means that it measures the interactions with the manikin, and also it communicates with the software, the controller software of the manikin itself. Why did we choose this type of manikin? The reason we chose this manikin is that if you have a manikin that has no measurements included, so it cannot measure the number of compressions, or it cannot show you any pulses, then the reality is missing inside this training. So this manikin has the options to record the interactions. This interactions is going to be submitted to the virtual reality software package to an API that is created and used to visualize in the control center software of Refence, and also able to review and debrief after the training. What we chose inside is that any wounds, like in an actual training, in a physical training with our virtual reality, we have to make the wounds on the manikin. And with a virtual reality or with a mixed reality environment, it is way easier to make the manikin in a way that there's like several wounds because of a bus crash, for example. I think you could go to the next slide. So this is a visualization of the manikin that completely wireless and tetherless. It means that it has no cables connected. It will communicate on Wi-Fi through a manikin server. This server creates has the API and creates the connection with the user interface of the virtual reality software package. With this system, it is really nice to see how you create an environment around the manikin, a physical manikin, in several different environments. So for a skill center, for example, or a training center, this creates multiple options to train several scenarios in the same space. So instead of having one room that is only subjected for one specific scenario setting. Now you're more flexible and create multiple scenario settings as well. For us as a company, of course, this is very interesting to see how this integration going to be generated, and of course how it's going to be used on the fields. So the fields trials are really important for us as well. Thank you, Helmut.
Thank you, Davis. So then our next speaker, then Pedro.
Hi, good morning, everyone. Yes, okay. So I'm Pedro, I'm the R&D manager at Plex Wireless Biosignals. So here in the MED1st project, we were challenged to develop a wearable or a set of wearables to measure stress, to help evaluate performance during the training or adapt the scenario during the training. So we know that stress indeed is a relevant factor for training, and we wanted to get a set of data from the body to allow us to compute this stress level for the users. The idea is that we can feedback this information to the scenario itself. Ideally, in a live view, we could adapt the level of challenge of the training, but also for the review during the review of the training, the users can also get the feedback of how they felt during the training and if it matched what the biosignals measured. For that, let's see if I can pass the slides. Okay. We started the project by trying to select what physiological data we could use to get this stress evaluation. Of course, we can have a set of a large set of sensors that could provide to get data from the body, but we need to make really a concrete selection of these sensors because we want to ensure data reliability during the acquisition, because people are moving in this open space. Movement generates a lot of artifacts in the type of on the signal quality. So sensor placement and usability was a key factor to select what type of signals we want to measure and what will be the final form factor for the wearables itself, to allow users not to feel that they are using additional hardware on themselves. What we selected in the end was based on an ECG sensor, so electrocardiogram signal. It's an electrical signal generated by the heart. So with that, we could measure the ECG trace, the typical, but also we could extract the heart rate and the heart rate variability, two main parameters for the stress evaluation. We also derived the respiration rate from this single sensor, and we added a movement sensor, so inertial measurement unit, to detect movement. This helps the computing algorithm to remove any movement artifact in the signal, and also to ensure that we have a reliable data source. On top of that, we want to add additional physiological sensors that could complement this stress evaluation, and we decided to go for electroabdominal activity, or also known as a galvanic skin response sensor. That it's essentially when we measure skin response to the stress, it generates some sweat, and we can measure this change in the skin conductance. And this is quite related to the emotional arousal or the emotional state of the user. This is something that it's being researched by the consortium also, how we can use this data to improve the stress algorithm. For this EDA sensor, we are also developing a specific wearable for that. That after several studies, we decided to place it in the back of the user, so near the trapezius muscle. And we decided to put it there because the user is already with some hardware for the VR environment, and we have to take that into account when we decide where to place our wearables that sometimes are not in the best location for the physiological signal, but it's a compromise between location, usability, and data quality. How did we integrate this in the system? You will see further details by my colleague Daniel. But for the wearable perspective, the wearables itself, they are a Bluetooth-based connection, so wireless connection. This Bluetooth connection delivers this data to a local gateway or a server that gets all the raw signals and manages the connection with the wearables and send them back to a server that manage all this and distributes to the different stakeholders. On the dashboard view, we will see the level of stress, and for now what it's decided is that we have some colors below the users that you see here in this picture, and these colors really relates to the level of the stress that the algorithm is computing for that user. So I think I will pass the word now to my colleague. Thank you so much for your time.
Thank you, Pedro. Good afternoon, everyone. This is Daniel from MED1st Research and Development, and thank you for joining this webinar. I will present you how all these pieces come together to create a seamless and effective training environment. Okay, so at the heart of the project lies a robust system architecture that connects different components, such as sensors, devices, mannequins, and performance data. This enables seamless data flow and communication between all elements of the system. The core of the system is the immersive VR environment, which, when combined with the patient simulation mannequin, it elevates realism and creates a truly engaging mixed reality experience. As highlighted earlier, we utilize wearable sensors to monitor trainees' biosignals and assess their stress levels, enabling the comprehensive processing of all the generated data. And this wealth of data not only feeds into the results dashboard, offering advanced insights to participants, but it also contributes to the scenario creation process. By effectively closing this feedback loop, our system continuously refines the training experience to maximize its impact on participants. The trainer dashboard is where the magic happens. It serves as a centralized hub for data generation and display, providing live monitoring of the various data inputs. This enables trainers to gain real-time insights and make informed decisions during the training sessions. Our innovative smart scenario control feature adapts training scenarios in real time based on trainee performance. And this dynamic approach ensures that the training remains engaging, relevant, and tailored to each individual's learning curve. To further enhance this training experience, we are developing an AI-driven approach to a scenario creation. Our trainer support service uses AI to suggest and create custom scenarios based on the specific needs of the trainees, maximizing the effectiveness of each session. We understand the importance of data security and protection, and that is why our system adheres to strict data protection protocols and requires consent forms to ensure that all trainee information is handled responsibly and ethically. This AI-driven trainer support service will identify stressors and root causes in trainee performance, promising tailored training content for an enhanced learning experience. We will also use advanced clustering techniques to group users with similar performance patterns, enabling us to create customized training scenarios that cater to the specific needs of each group. Time series analysis will also track trainee progress over time, helping our AI system identify areas of improvement and provide timely feedback for continuous growth. By analyzing also audio transcripts, our AI system will assess communication efficiency between participants. This will enable targeted guidance and more focused interactions, ultimately improving the overall training experience. The idea is that our AI-driven approach will act as a decision support system that assists trainers in making informed decisions adapting the scenarios to keep the sessions engaging, relevant, and impactful. In summary, this trainer support service is poised to leverage cutting-edge AI approaches to create a highly effective and personalized training environment, delivering a truly parallel learning experience. Now that we heard all the aspects from the different technologies within MED1stMR and how they all come together to an end-user-oriented solution, I now hand over to Birgit again. So she will give you some information on the solution advantages and the next steps and events in the project.
Okay, thank you, Daniel. Okay, thank you to all the speakers today from our technology partners. I think what we saw is that the MED1stMR project is consisting of many different components, but they all come together for one solution. And the idea is to create a solution that has a lot of advantages for the users. And we tried to sum them up for you a little bit. We see different target groups that are using our solution. We have the trainee themselves that are actually in the VR student experiencing the scenario and using the manikin, getting measured, and they have this big advantage of a realistic training and a haptic experience. They have an active learning experience and they learn how to cope with stress. But at the same time, there are the trainers that want to provide the trainees with a good learning experience, and they have the big advantage of in this solution that the scenario and the flow of the scenario is repeatable at one click. So if the trainer has to stop or has to give some advices in between or whatever, it just stops the scenario and the flow and can start at any time or adjust some surroundings and the scenario is going on. At the same time, the trainer can steer the flow of the scenario. So if the trainee is too stressed or not stressed enough, the trainer can change the situation. And at the end, and that's very important for the learning success, the performance is measured and the stress is visualized, as we have seen in the trainer dashboard. And based on this evidences, the trainer can decide how to move on or to steer the training in between. And there are these two parties that are in the training themselves, but there are also the policymakers and the decision makers that think about introducing such a technology to their organization. And they can make sure with such a solution they have a safe training environment. They have a European training framework because, as you have maybe heard in the last webinar about the research, we also produce a training framework with descriptions how to train in such a mixed reality solution. And at the end, a decision maker can be sure that it's a resource saving solution for its organization. So that's the idea of MED1stMR. And what's important for you to know is that there is a lot of going on in this next 12 months of the project. These are the last 12 months of the project. And the next step is that we want to test this solution that we produce now with all the technology partners, with the input from our end users and with the scientific backbone, with the research. We want to test it with our end users. And there will be 6 end user field trials within the next few months and on all different locations all over Europe. And each field trial will last 1 week. So in the end, there will be more than 200 end users testing out the system and doing a real training with trainers that we all together in the consortium trained. And they were educated in mixed reality training and with our system. And then we will do a lot of research and get a lot of feedback during these field trials and develop the solution further. And the good thing for you is that you can join us at these field trials if you want. You can write us an email if the location is close by and you can come over, or you wait until the end of the project and then you join us at the final conference in Randst in Belgium at Campus Wester. And there you can also try out the system and find out more about the technology. So we have a lot of events upcoming. We have these 3 webinars now. Then we have the 6 field trials at our end user partners. We also have 2 real-life exercises where we compare the different aspects of mixed reality training and real-life training. Then we have 1 more webinar, also from our end users, that will give you insights on how they experienced this solution in the training sessions. And at the end, there is the big final conference where you can meet all our researchers, technology partners, and the end users and find out more about MED1stMR. So if you are interested, just drop us an email and let us know wherever you want to join us. And now I will open the questions and chat, and we will answer your questions. Okay. So let's see which questions we have. There are at the moment no questions. Just open the chat. Okay, there's also nothing. So if you are happy and all your questions are answered, probably wait 1 more minute. Okay, there is 1 question. Where are the biggest challenges from a technology point of view?
Yeah, maybe I can jump into that. The biggest technology challenges here are, the combination of all the things. So we know already, so the VR training system is already in place for police training. The mixed part is the challenge. So, and on the other side, the manikin is already a final product, so you can buy it for classes training. You can use it so in the field or in the classroom, you can do all the training. So it's a highly sophisticated manikin already, but bringing the things together that it works as we want, so in a synchronous manner, and that the things also with what you are doing with the manikin system talks with the VR system and stores the things, analyze the things, and give all these things together can be used in debriefing and to go through the details. These are the most challenging things, and beside that, sure, we have this plug sensors with the measurement of the stress. This is also a challenge because measuring stress is not that, say, 100% reliable. So you measure something and then you had to come up with a sophisticated model that says it's stress or not, or is it like exhaustion or movement. And these are also like a challenge in itself. And behind that, there is a lot of data. Is when you think on full body tracking of 4 people, storing everything, also with logging, with scenario events. So storing the data, analyzing this data for the debriefing is also like a challenge to make this available instead after the training, so that you can go through the things. So having this together then for the debriefing, these are the several challenges for the aspects.
Okay, Harold, we have 1 more question, and that's a question we actually heard quite often over in the past and since the beginning of the project. The question is about can you purchase this system, and when will it be fully developed and available for to buy it? What can we say about this? Yes, it's a project where our aim is to develop something that is really usable.
Sure, at the end, so there at the end we will have something where you can start training already with that. So, and sure, that what is in the project, it's research. So the thing is that what we have at the end, it's has a scientific foundation. So it's not a game at the end. So it will focusing on learning goals. It will focusing on learning itself and how it can be used in education and training. So that means it gives directly you something how you can talk to your decision makers, policy makers, what the thing will bring for you. And we have, let's say at the beginning, some scenarios what you can train. So we are going for first triage training, second triage. We will extend it also like more or less than for situation awareness, focusing on communication. But at the first, we are focusing on the learning goals for the medical skills because we are focusing on the integration of the mixed reality and on the manikin. And sure, after the project, we will start with extending with further funding, or at least so with further projects. So with additional scenarios and solutions integration.
Today we had all our technology partners in the webinar. So you met them. They are from real companies, so they are interested in producing something that can be sold afterwards. So that's actually really one big goal of the project, that it doesn't end with the project itself, but there will be a product afterwards. Okay, we have one more question. That's more about the mannequins. It's about, do you have different type of mannequins? Not in the project, but there are a lot of different types.
There are, in the project we have 2 different types. So because it's always that what comes up with, can I purchase it? And the next question is, how much does it cost? And depending on that, what you want to train, is it first triage or is it second triage? For first triage, you don't have that many things you will do in first triage. So, and that's the thing. So tailor-made a mannequin only with the features that are needed for this training. So that makes it affordable, also like for lower goals. And then having the highly sophisticated one for second triage, doing a medical post simulation or something like this. And sure, this is then also a question of price, and it's configurable and they're adaptable to the needs to the customer.
Right. Yeah, thank you, Helmut. Okay, so I think we have answered all your first questions. If there are any more questions, you can contact us directly. Also after the webinar, and the webinar itself will be recorded. The recording of the webinar will be available afterwards. Okay, so a big thank you from here, from Vienna, but also from all our partners in Europe. And hope to see you in the next webinar, which is hosted by our end users, and you will see their point of view on all these developments and their experience with mixed reality training. Thank you.
Thank you, Birgit, for bringing us through the webinar, and thank you for joining us. Bye.
See you. Bye.